Thank you again, Bonnie. Like she said, my name is Sean Massey. I'm a consultant and a data center engineer with, help me turn this on. I'm a consultant and data center engineer with a company called Ahead. They're a data center engineering firm based out of Chicago. I'm part of their mobility and end user computing practice. I'm also a blogger. I blog at thevirtualhorizon.com. I'm active on Twitter and on LinkedIn. I'm also a V expert. My focus is mainly on end user computing. And as Bonnie said, I'm on the steering committee for the Wisconsin VMUG, so I am also active one state over. No, I am not a Packers fan. I'm originally from Chicago.
Go Bears!
Go Bears. I won't say what other team I root for. I feel like getting home tonight. So let's kind of start by level setting a little bit and talking about what end user computing is. I think Sean talked about a lot of what EUC is and modern EUC is in his keynote earlier today. But Workspace ONE is just a small subset of that, and he didn't really go into all the features. There is a wide swath of technology that's covered under modern end-user computing. That includes virtual desktop infrastructure, server-based computing, which is XenApp, server-based desktops, but a whole bunch of other mobility technologies also go around that to build large ecosystems. It's stuff like enterprise file sync and share technologies, like ShareFile or Dropbox, Box for Business, mobile device management, AirWatch, which is a key component of Workspace ONE that Sean talked about earlier. But that also includes things like Zen Mobile, Good, and other competing technologies. User environment and user profile management. If you were in the last session, I think Tyler talked about that for Liquidware. And then endpoint management software. So that's things like SMS, Mirage, SCCM, Altiris. It's not really modern end-user computing, but it falls into that space because end-user computing really touches anything that deals with services delivered to the user. So if we're giving our users one of these, we still have to manage it. That would fall under the scope of end-user computing. There is some core infrastructure that, while it may not be solely end-user computing focused, it still kind of falls into that bucket. That's things like printing, Active Directory, identity management, and tools along those lines. So why do we do it? Why do end-user computing? Why do we have an event like this today? So modern users want access to their applications and their data anytime, anywhere. Think about this. How many of you guys have one of these? I should see every hand in this room going up for having a smartphone, right? These tether us to our jobs. That's the honest truth, right? You know, we get our email on these 24/7. If there's a Sev1 alert or a code red or whatever term you use for it, you've got to be able to log in and fix that problem. It doesn't matter what time of day. It doesn't matter where you are. So we need the ability to access anything, or our data, our systems, anytime, anywhere. Businesses also want flexibility and agility, right? Under the old way of doing things, deploying physical PCs, if somebody called you up and said, I have 100 users coming in next Monday, I need machines for them, what would the response be, right? You'd laugh at them and say, all right, that's going to be 2 weeks, right? You need to give me more time. With modern end-user computing solutions, somebody calls up and says, I need 100 users on Monday. It's like, okay, we'll have it for you. What applications do they need? So we can be much more flexible and much more agile in delivering services to end users and to the business. The other nice thing is it can improve business continuity and disaster recovery. If we design our environment right, if something happens to either leave a smoking crater in our corporate office or in our primary data center, our users will still be able to get in and work no matter where they are. As long as they have a functioning internet connection, they can work. So I'm from I live in Northeast Wisconsin. Just like Minnesota, we get a lot of snow. A couple of years ago, about 2 jobs ago, we had a couple of days where we had 12 inches of snow overnight. They closed the office, but because we had a VDI solution, business didn't stop. People were still able to work even though they were at home and they had their kids with them. So why don't we do VDI? Or what's a reason not to? Unfortunately, saving money is not something you're going to do when you do a VDI solution. There's a lot of complexity to it, a lot of new data center infrastructure that you need. So you're not necessarily going to be able to show cost savings by going to a modern end user computing solution. But there are a lot of other benefits that may have intangible costs or soft costs that you can't show back to business. Ultimately, what it comes down to, though, VDI will transform the way your users and your business interacts with technology. So how do we design it? So there's a couple of things here. We're gonna go much more in depth into all these topics here. So the first thing you need to do when you're thinking about doing a modern end user computing deployment, or deploying a modern end user computing environment, I should say, is you need to understand and define all your use cases. This is the most critical part of the process. Then you need to gather your requirements and constraints, identify any risks, and also identify critical success factors. Once you have those, you move on to selecting and evaluating technologies, and then that's where proof of concepts come in. That's when you start thinking about pilot projects. And then we're also going to talk about some key design considerations for your environment. So what's a use case? Use cases are central to VDI, to any end user computing project. Everything in EUC starts with them because you're doing something that's user focused. So what a use case is, it's basically a group of users with common requirements, common applications, and common ways of doing things. So what's included in that? The type of user. Am I dealing with a general business user in accounting, or am I dealing with a student? Or am I dealing with somebody who deals in very high-end applications like CAD or 3D graphics enabled applications? What work styles and processes do those users have? How do they do their work? What's their workflow? What applications do they use? Do they need to access it remotely? Is there any requirements for multi-factor authentication? There's a million other things that can go into feeding a use case, and I'll show an example on the next slide of what a documented use case might look like. But what it comes down to really is you can't gather any additional requirements for your environment until you understand your users and their applications. Right? VDI is not as simple as going out and buying a rack of servers and some really fast storage and saying, okay, here, use this for your desktop now. If you don't understand what the users need, if you can't show that you understand their applications, it's not going to be a success. So when it comes time to identify a use case for you, well, for starters, you need your desktop or end user computing team. You also need your applications teams. So as you start identifying your use cases and you start identifying the applications that users use, you bring the application owners in. You definitely 100% need your security team involved from day one. Right? By having your security team in there, they can be an important ally for you in getting this project off the ground. Especially if you can show that what you're proposing as a solution is more secure and fits in the policies that they want to implement, they will back it 100%. But the last thing you want to do is design a VDI environment and then take it to security and say, oh, hey, we're doing this. I can't tell you how many times I've been on a project where security is brought in either at the end of a design session or as an afterthought, and you show them the design, and then they go like, no, we can't do this. This doesn't meet any of our requirements. You're going to have to physically segregate third party from internal. It's like, oh, well, that's going to double our hardware requirements. We don't have the budget for it. Like, well, that's too bad that this isn't going to happen. And that has happened. It's a very painful and costly mistake to make. So have security involved from day one so you can gather their requirements, because it's going to be very important, especially if you need remote access. You need your infrastructure team involved because this is going to go into a data center. This is going to be stepping into their domain. So they're going to have their say on, or they're going to have their thoughts on what hardware should be purchased, how it should be managed, how it should be architected. So they need to be brought in and have a significant amount of buy-in on it. And then while they don't need to be a formal part of the process, it is important to include your end users. So while you're having architecture meetings, you don't have to have end users or power users there, but you need to talk to them. You need to shadow them and see how they do their work, what applications they do. Because if you overlook how they work, if you don't ask key questions on how the process works or how components go together, you're going to miss requirements. And then you'll have to go back and re-architect the environment after you're in the pilot phase, which can also be a costly proposition. So throughout this process, you need to work with your key stakeholders and kind of bring everything together. And as you identify your use cases in your current project phase or in your future project phase, like put it into a spreadsheet. And what we can see here, I forgot what I put out there. As you can see here, we identified the number of users, whether we're doing, a traditional VDI or published application environment, what type of desktop it is, our OS, applications, and all these requirements. So as we sit down and start figuring out how our environment needs to look and how we need to architect it, we have all of our details of our use case calculated and figured out. So once we know that, then we can kind of move on to other key factors of the infrastructure. What requirements do we need? What constraints do we have? So I'll touch on those two first. Requirements are features or functions that have to be implemented in the environment. This is something you have to have. So if I'm building up the environment, my security team says, we need to use two-factor authentication. That's a requirement. Our desktop team comes and says, we're looking at Windows 10 in a year out. That's going to be a requirement for something to support Windows 10. Constraints, on the other hand, are things that limit your design choices. These are things that kind of block the road. They're roadblocks into getting specific technologies. Examples of that, we must use a certain vendor for a certain component. So if we have a purchase agreement with NetApp or EMC, we have to use them for storage. That's a constraint. You can't use iSCSI as our storage protocol because security doesn't want to implement secure iSCSI over the network. That's a constraint. The thing we have to realize, though, is that people get restraints and requirements confused. We have to remember that a constraint limits your choices. It's saying, no, you can't look at this technology because we already have a purchase agreement. We've already bought this technology. You have to use it from this company. A requirement would say, well, you just need really fast storage. It doesn't care where you're getting it from. Risks. A risk is anything that you have to mitigate in order to have a successful project and a successful deployment. This could be any number of things. It could be a functional risk or it could be a non-functional risk. It could be things like your procurement timeline. If you have to implement VDI by September 1st, and it takes 6 weeks to get a PO cut for procurement, well, if you bring it to them August 1st, that's going to be a risk. You're not going to hit your procurement timeline to be able to start implementing on that date. Or it could be something users have brought up. Maybe you've tried a project like this before and your network couldn't handle it. So a risk could be that your users may reject this because of a past experience. And finally, we need to know how we succeeded, and that's a critical success factor, right? How do we quantify that our project was successful? How do we know that we accomplished our goals? So, maybe one of our goals is our users are able to get their data anywhere. So we'll be able to show as a success factor that a user can pull up their iPhone and log in to a portal and access all their files. We can also quantify it by sending out surveys and saying, if we hit 90% on our satisfaction, our users are happy, we succeeded. So once we kind of know what all this is, once we define our requirements and constraints, we have to gather some information to kind of round out and justify those. Some sources of that, company standards, review your standard stocks, existing policies. If you're in a regulated industry, You do have to look at government regulations to see what's applicable. So this may apply to healthcare, finance, education. And then finally, you have to go and get a budget. None of us have an unlimited budget, so we kind of have to know what we're allowed to spend when we architect it. So we've done all that. Now we have to move on to selecting and evaluating technologies. Right? As we go through our requirements, we have to kind of weigh what's important today. What are we doing for our first use cases? What requirements are going to be most important for those? Right? But we also can't forget what we need for tomorrow. One of the last things you want to do is box yourself in by designing for today and not planning for the future. VDI end user computing can be a very capital-intensive process or project. So if you spend a lot of money today and you made a mistake, then you have to go back and ask for money. The business will not be happy. They may grudgingly cut that check, but you want to avoid that early on, right? So think about what your future use cases are going to be when you're designing for your initial ones. It's also nice to know what's nice to have. So when you look at your list of requirements, some things that are on there may not actually be requirements. They're just things that we would like to have. Maybe it's something for a roadmap item 5 years out. So it's worth noting that kind of in a lower priority on your checklist, that if it can check that box, it's great, but if it can't, we can do without it for now. And then internally, when you're starting to look at different vendors and you're talking to them, check with your teams. Do you have anybody who has a skill set or who's done something like this in the past? Have you previously worked with a vendor? Some customers that we work with, they've been all Citrix. They have a really good Citrix skill set. So it doesn't make sense for us to put VMware Horizon in front of them unless Citrix isn't meeting their needs. So that's one thing to keep in mind. As you're looking at technologies, have people on your staff, work with Citrix or Horizon or other technologies and leverage that when you're doing your project plan. So it's really important to sit down with the vendors, to sit down with trusted partners, if you work with a VAR or two, and kind of hash these out with them. Discuss what you need. Don't just say we want to put VDI in or we want to put ZenApp in, because we'll sell you that. Is it the right fit? Probably not. So sit down and discuss what you need with them. Take the time and actually do a design with them. It will be very helpful as you work into your project that you know that yes, we've met all our requirements. We've worked with our partners to say that yes, 9 out of 10 of our items will be accomplished with this solution. If a vendor can't meet a requirement today, though, if you say, well, we needed to do X, and it's not there, ask to see if it's on the roadmap. Not all vendors will do that, all right? I'll be honest with you. A lot of vendors won't say, yeah, we're working on it, we expect to have it, by Q1 next year. And if they do that, you can ask to have an NDA briefing. Some vendors, I know VMware does it, Citrix does it. If you ask to have them come in and you sign an NDA, they will talk about their roadmaps. Especially if it's holding up a purchase, a very large purchase. But most importantly, when it comes to selecting technologies, don't cut corners or cost. Right? This is very important. If your budget won't allow you to do everything you want to do today, look at scalable technologies. Storage and compute have come a long way from even 5 years ago when people were first talking VDI. And you can now buy storage that if I need capacity or performance, I just add a node. In the past, it was I had 2 controllers and I had to add shelves of disks. Now, I can just easily scale that out. So proof of concepts and pilots. You kind of narrowed down your technology choices. You want to put some stuff in, see if it's going to work. So there's 2 ways people usually do this. First off is a proof of concept. This is a very limited scale test just to see if something is going to work. Yes, my applications will work. Yes, I can publish this out and the vendor is going to support it. It's not performance driven. It's not intended to be production. It's very limited scale. This may also require your team to be somewhat hands-on. If users are, if a couple of test users are in it and they're saying, well, we're not quite sure how to do this, we're not quite sure if this is going to work for us, you may need to shadow them and see what they're doing, follow their process. As you go through this, you may have to make adjustments to your requirements or to your design. A pilot, on the other hand, is or should be designed for production. It's still a testing environment, but it's one of those environments that I'm going to put it in, I'm going to do a test that's going to be much larger, maybe a use case, maybe two, and then if that's successful, I'm going to roll it into production. And those users are going to become my first production users. So it's wider, it's much wider scale, and they are often the first implementation phase. The one key thing I want to point out, or two key things I want to point out here, as you go through this, you have to have clearly defined success criteria, right? You can't just set up a pilot and say, okay, well, we're going to try out, Horizon. If you don't know, okay, well, we're going to try out Horizon and we're going to test that, our core line of business apps work and our users can actually do their job in it, you'll have a very limited scope and your pilot will come to an end, or your proof of concept will come to an end. And you'll know if that will actually work for you. If you don't set criteria, it's just going to keep going. Yeah, you're going to have like 5 or 10 users in it, and it's going to slowly replace their desktops, but you've never truly evaluated anything. And then when you shut that down one day, you'll have a very small user revolt on your hands, because you didn't know they were still using that. So it's got to be limited. It's got to be clearly defined success criteria. As you go through this too, you need to ask for feedback at every step. You have to have some sort of quantifiable way to ask the users, is this working for you? Are you being successful with your job by using this technology? Oftentimes it's a rate on 1 to 5. Is this working? Is this not working? Is it successful? Is it not successful? 1 to 5. But also try to get some more free-form feedback. You can't always capture everything on a scale of 1 to 5 or 1 to 10, so you have to get comments from them as well. It's important too to follow up on any comments that they might have. If they're saying, well, it's kind of slow, between 12 and 1, and it's really hard for me to do the work, then maybe you need to sit down with them or look at your network logs to see, okay, well, what's going on between 12 and 1 that would cause a performance issue? And then ask the question, well, would this cause an issue if we roll this into production? Along the way, it's important to have some good monitoring tools. I'll call out Liquidware again in the last session. They talked about Stratosphere UX. That is one of the really good tools. If you're doing a pilot or a POC, sign up for the 60-day trial, put it in. Just use it for the trial period, just to get some additional information to see if your pilot and POC are on the right track. All right, so let's talk a little bit about some of the key design criteria that go into building end-user computing environments. Now, the first thing you'll hear about when people talk about VDI or end-user computing is persistent and non-persistent desktops. So let's kind of talk about what these are and kind of level set on the technologies. Persistent desktops, I guess the best way to put them is the pets and cattle analogy. How many are familiar with pets and cattle? So the analogy between pets and cattle in IT terms is you have a pet. You love your pet, you care for it, you feed it. If it gets sick, you take it to the vet. If you have cattle, you have a whole herd. If one gets sick, you send it off to the knackers to have it processed into meat. The same holds true in IT environments. A pet is a server or a virtual machine that you care for, right? You built up one server for your application. You have to care for it. You have to patch it. You have to back it up. You have to make sure that if something happens to that server, you get it fixed because the business depends on it. Persistent desktops are pets, right? The user gets that desktop every time. They log off, the state of that desktop stays the same. It's like having a physical machine, but it's just in your data center. Right? Non-persistent desktops are like cattle. I'm cloning that thing from a template every time I need a new one. If something happens to it, I have the user log off, I delete it, they log back in and get a new one, and they're good to go. Oftentimes, non-persistent desktops are built on technologies like Citrix MCS or linked clones, or hopefully in the near future, if or when it's released, Horizon 7 will have instant clones. So, these are technologies that enable you to deploy a lot of desktops. They're all the same. If something happens to them, user logs off, you delete that desktop, and it provisions a new one for them. Some of the key differences, though, between these two technologies, persistent desktops, they're oftentimes full VMs. It's just like a server VM that's in your existing virtual infrastructure. Like servers and traditional desktops, they need to be managed and patched. Right? You don't have to manage the user profile because that stays on the machine. That user gets it that same machine every time they log in. So like a regular desktop sitting at their desk, they get their same settings every time because they get that same machine. But they're not disposable, right? If something happens to it, I have to fix it, or I have to spin up a new one for that user, and that user goes through the pain of moving their applications over, reconfiguring all their settings, making sure they didn't lose any data. One key point I should point out here too with persistent desktops is if you go that route, you do have to consider backing them up. Because if you have a DR event, that desktop goes away. You need to have a way to either replace that desktop or to move it over to a new data center just to spin it back up. Non-persistent desktops are, like I said earlier, they're cattle. User logs off, it goes away. So I don't have to manage each individual desktop. I just manage one master image. Whenever I need to make a change, I update that image, I redeploy all my desktops. Because that user may not get the same machine every time, I may have to use a profile management tool to capture their settings and move them over to, the network, a network file share, so that way when they log in somewhere else, those settings can be pulled back down and be applied to them. But ultimately, these are disposable. I don't care what happens to these desktops as long as I have a pool of them running. If one of them breaks, I get rid of it and I move on to the next one. There is a third option, though. That option is called server-based computing. This takes what we see traditionally as remote desktop session host, terminal server, and XenApp, Horizon application publishing. This is what that technology is based on. I use Windows servers. I can provide a limited number of desktop sessions or single published applications out to users from that server, so multiple users will be logged in to that one box. This uses a different licensing model than traditional VDI. The licensing model used here is server-based. I'm only buying CALs. I don't have to worry about licensing the desktop OS inside my data center. And generally speaking, these are non-persistent. Users don't always get the same server every time they log in, so I still need to do some of the profile management stuff. But I don't have to, but I do care about the server, right? If that server breaks, I may be impacting more users overall. So which should I use? Well, it depends, right? One of these options is not better than any of the others. It clearly depends on your use cases, right? So while there may not necessarily be one right answer, there may not necessarily be one right answer for this. Applications really play a big role in your decision, whether to use persistent, non-persistent, or server-based. And really the main reason for that is persona management. So two things actually. Persona management technologies, not all applications play nice with them. Right? So some applications, they like to store their data in out-of-the-way places that are really hard to reach by persona management tools. If an application is that way, you can't use a non-persistent model. Other applications have odd licensing restrictions where they're licensed based on MAC address or host name. In those cases, you have to give that user the same machine every time. You can't recompose it because if you recompose it or replace it, it may get a new MAC address or the host name may change. So in those cases, you would also have to go with a persistent model. I have also seen cases where some companies' legal and security requirements said, if we have a security incident, we need to quarantine that VM so we can run forensics on it. With most non-persistent models, you can't do that. Right? When that user logs off, that virtual machine gets rolled back to a known good state, or with instant clones, it goes poof. In an environment where you have those kinds of security and legal hold requirements, you can't use non-persistent desktops. So it really comes down to understanding what your requirements are and what the requirements of your use cases are when you make this decision. Ultimately, too, there are trade-offs between them. Now, we've talked about a lot of these trade-offs already earlier, but I just wanted to put this back up here to remind everyone that if I choose persistent, here's the trade-offs I take over choosing non-persistent, or vice versa. So these are design decisions that you have to be aware of when you're planning your environment. So another key consideration, disaster recovery and business continuity. Right? Just like your current data center workloads, it's very important to protect your virtual desktop and user computing environments. It's especially important for business critical users. So every business, has users who, in the event of a disaster or a DR, a business continuity event, they would be priority over other users. The same is true in a virtual desktop or a user computing environment. Early on in your process, when you're going through your use cases, you need to identify who these users are. So you can prioritize them or prioritize their use cases when you're designing your DR plan. So there's two places where you need to consider redundancy and disaster recovery. The first is within a data center. You need to have multiple components at every layer if the environment supports it. So multiple connection brokers, multiple remote access gateways. You need to look at using load balancers to make sure that if one server fails, users will be able to reconnect through the other. But you also need to have a second data center of some sort that you can use for a disaster recovery plan. You need to test that disaster recovery plan. And bring these new use cases on. Yes, we can fail them over to this other data center, and our users can still continue to work. So the reason why I'm putting so much focus on this here is, under the current model, if you're deploying a physical machine to all your users, if an application goes down, if there's that fiber-seeking backhoe that cuts off your connection to your primary data center, users can still work, right? They may not be able to access all their business applications, but they can still do work on their machine, right? You can still use Excel, Word documents, things like that. But if I put my users into that same data center where my applications are, and then I can no longer, and if an event occurs where I can no longer access that data center, none of my users can work. Nothing happens. You might as well just say, hey guys, pack it up and go home. We'll call you when we get this fixed, then you'll be able to work again. So you need to plan for having something to say, okay, yeah, we had an event, but we're spinning everything up over here. Business will be back to normal in 4 hours. You'll have a desktop for you. When you plan for your DR as well, like your business applications, you need to set clear SLAs and expectations. Right? What's going to happen if I have a DR event? How long is it going to take for me to get new desktops up, and where does that fall within the priority? And what can users expect? Am I going to get my same desktop, or am I just going to get kind of a blank template that's going to get me up and running until we can get the other side fixed? So, what you do from a technology standpoint, as you go through and select your vendors, this will heavily impact your disaster recovery plan. There are some limits to the technology today in certain cases that you'll have to design around. App volumes, for instance. If you're using app volumes with vSphere and you're storing them on VMFS data stores, there's no replication technology with the current version. So if I go in heavily on app volumes for layering apps onto non-persistent desktops, I have to have a plan to make sure that if my primary data center goes down in some way, that I have those app stacks available in my other one. So that's an example of an important design consideration for business continuity. And again, I'll touch really quickly on licensing here. Licensing can have huge implications on EUC deployments. Right? The big driver of this is going to be Microsoft licensing for virtual desktops. Microsoft has VDA. It's got its own complexities, that's all I'm going to say about it. And the best person to talk to about that is going to be your Microsoft licensing rep. By the way, if you talk to more than one, you may get more than one answer. As with anything Microsoft licensing. So, but it's important to understand that, the impact that Microsoft licensing can have. Now, there are alternatives to that. If you don't want to pay the Microsoft VDA tax, you can use Windows Server licensing for virtual desktops. And in those cases, you're paying for Windows Server Enterprise and CALs. So there is a simpler model available. However, a lot of users will notice that they're not on Windows 7. So there's trade-offs there. Some applications may also not be compatible with that sort of model. The other big thing to be aware of is application licensing requirements. As I mentioned earlier, in the choice between persistent and non-persistent, some applications are licensed based on computer name or a hardware element, like the MAC address. So it's important to know what those are when you design your use cases. Sadly, hardware dongles still do exist. So if you move to a virtual environment for users of that particular application, you may have to come up with an alternative solution, like USB to Ethernet. I mentioned AutoCAD. That's an example of an application that has network licensing options, so you may have to convert to those. Office 365 generally likes to license to specific machines. So if you don't have a SKU in Office 365 that includes Pro Plus, you may have to upgrade, so there will be additional costs there. I will point out, too, that there are some VDI-specific application tracking software tools in development. So if I want to know who's using licenses in my environment, there are tools that are currently being worked on that will solve that problem. You won't have to put the SCCM or Altiris agents on your virtual desktops just to get that information. Thank you guys, great, and remember to fill out your surveys. I don't know if Matt told anybody this, but if you want to win one of those Synologies, you have to fill out your survey and you have to put an email address in. That's the only way you'll be able to win. So.